Schönen guten Abend. Good evening, everybody, and a very, very warm welcome to our very first Genesis Talks. We are very happy that you are joining in for our today's very first event, which is hopefully a journey of many more to come and of a broader vision to be built here in Munich. We are very much thrilled to have Enzo here, straight from Palo Alto, who is deep diving us today in DFINITY, in the project he's working on. Before we're jumping on the topic, just a few remarks on the agenda today. I would just give you a brief insights. Who are we? 2 minutes. You're probably not so much interested in that. And then we will tell you a little bit about our vision, what we are planning here in Munich. And this probably takes 10 minutes altogether. And then I would hand over to Enzo to get some really interesting information. So who are we? So here are some people from Creative Doc, some colleagues, some friends, and we have Staking Facilities guys here, which are by now also friends and colleagues. We were building, Creative Doc is a classical company builder. We have a 6 years company history, so we are still young, a little bit also still a startup ourselves, I would say, with 300 people working in 6 nations, building companies, building startups for institutional investors, but also private investors. And what we recognized over the last, I would say the last 12, 18 months, is that huge interest coming, especially from corporates, into the blockchain technology. They know a lot about blockchain technology. No, they don't. The only thing they know is the Bitcoin, and the Bitcoin is not our best promoter, I would say. But saying that and knowing that there is so much interest, we were like pushing internally very much and building teams, building knowledge, and building also projects, which is aiming at further promoting the technology. We believe that blockchain is a disruptive ledger and will disrupt how we do business and what are we doing and how we do it today. Currently, some last word to what we are doing. Currently, we are working on a execution project in Zurich. So we as Creative Doc, we are helping a company which just had an ICO, which raised like 10.7 million euros, and we are helping them building their company. It's valid, it's public, I don't have to hide this. Valid is a digital wallet owning your data, and you are in full control of your own data, which is generated on Facebook and Co. And you are able to put a price tag on your data. So you are in control and you're selling your data. And this is Creative Doc, very brief internationally. And I would like to hand it over to Julius real quick, who gives an insight about staking facilities.
Yeah. Hi everyone, also from my side and from the whole Staking Facilities team. We are actually 3 guys. You will recognize them with the white t-shirts. So what we do is basically we provide consensus infrastructure for blockchain projects. So we have a portfolio of several projects we are following, and what we basically do is we run the software or the hardware and software which blockchains run on. So we do a lot of research and also host events like this one, and hopefully a lot more in the future. Yeah, and that's where we met Creative Doc. Basically, Robs, who is sitting in the back, is a friend of us. He's working at Creative Doc, and so we came together with the idea of doing this whole blockchain thing in a bigger scale. So Phil is going to tell you what our plans are in the future, and yeah, we'll see.
Okay. What I said, we have a vision, and I think everybody knows Berlin as the startup hub. Berlin is like the top tier when it comes to blockchain, to other technologies. Everybody want to sit in Berlin. We want to balance this a little bit. We think there is a place in Munich. We have InsurTech. We have insurance companies sitting here. We have huge finance companies, banks sitting here. We have mobility companies sitting here. So we think it's about time to organize us a little bit better and put the brains which are in Munich. There is a big community. It's just not so well organized yet. That's why we are about to launch the Genesis Hub. The Genesis Hub, which it's a it's still a baby, right? Its main target is let's work together, let's connect together. And it's not only about connecting us, the techies, it's about building a bridge between potential investors, between corporates and the tech experts. Because what is the big pain? There are some tech experts out there, and a lot of people are talking about blockchain, but it's very hard to get a hand on them. So we want to build this place where we can connect these three stakeholders. We want to innovate. Yes, let's build use cases together. We just came here. Enzo was saying, you came to coding by cheat. How do you say cheat? What are the papers?
Cheat sheets.
Cheat sheets. That's why he got to coding. We are not want to go into this direction of scammers, of course. There's so much scam out there. But let's find some really cool use cases together. And maybe if you are lucky and we have the connection to the corporates, we can have something, a playground where we can install them right away. So we want to work together with the big ones, with the corporates, with potential investors. And last but not least, let's join in for a nice coffee. So what is this hub about? We drink together like coffee, maybe some beers in the evening. We want to build facilities, we co-work together, and we have these events not hosted here. We will have it in our own Genesis hub. And for everybody who says, well, cool idea, I want to join this movement, join us. So we are looking for people who want to join in, who want to help. We're still looking for a really cool place. So if anybody has an idea about a good venue, a good facility where we can jump in, yeah, just get in touch with us, and we would be happy if we get as much as support to build this non-profit, by the way, Genesis Hub. Thank you very much.
Just a few things. We talked to Enzo, and we're going to do a long Q&A, so it's going to be a short presentation and a lot of Q&A. So you're welcome to ask as many questions as you like. And for that, we're going to pass around the mic. And we also have this cool tool. It's, if you go on the website Slido and you're listening to his presentation, you can actually pass in the word DFINITY, that's the code, then you can join and fill in your questions right here anonymously, and Wolfgang, who's going to do the Q&A, will ask all the questions you just put in there. But we're also going to hand over the mic to everyone. So just for you, feel free, if you have any questions, type them in, and so we'll ask them. So basically that's it from our side, and now you can enjoy the real stuff. And Enzo's going to present... yeah, after the event, one short thing. We have a lot, we have some beverages, drinks in the networking area. It's right around the corner and then to the right. We have some snacks and stuff, so feel free to come. We will be around, so if you have any questions, come to us. We're happy if we can answer you. So, let's go on. And so, your turn.
Thanks. Thanks so much. I cannot even articulate how excited I am to be here with you guys. I've been working on DFINITY for a little over a year and a half now, so it's really great to see so many people under one room who have the same kind of interest and enthusiasm for the project that I do. Yeah, so like I said, I joined the project about a year and a half ago, and I mean, we've seen a tremendous amount of growth and interest, and it's really just by chance that I got to be here with you guys today. I was in Zurich for the Zurich Hack 2018, which is the largest Haskell hackathon in the world, and Haskell is the primary language of implementation that we use to develop DFINITY. And just here for that, and my colleague couldn't make it, so I'm subbing in for him, and I'm glad to be here with you guys. Okay, great. Yeah, so I just want to talk to you guys a little bit about what it is that we're building. Many of you are maybe familiar, which is why you're here, and some of you may not. But so DFINITY is building a general purpose computing resource that is shared over the internet. And so when I say general purpose, I mean that this computing resource will allow end users to run applications in the widest variety of application domains. And by shared over the internet, I mean that the computing resource itself is actually created by a network protocol running over the TCP/IP stack. So let's just kind of try to build some intuition about what that is and how we came to build this. So just looking at the evolution of some computing resources, we know that a computing resource is something that can be specified as a mathematical model, and that was done famously by Alan Turing. That could also be implemented in physical hardware then, which is what we get when we see a physical machine. Also, actually, maybe not pictured here, but that the idea of a computing resource is something that can also be implemented in software as a virtual machine. And then here, kind of with DFINITY, the idea is that this is sort of like a shared virtual machine that is created by this, this network of computers. And so, oh, there we go. Okay. So this network of computer gets together to create this virtual machine. So how does that kind of work? Maybe that's a new concept to some. So to start with, I mean, running any network protocol requires collaboration. It's true even for HTTP, for example. If the client and server aren't working together, you don't get very far. And it's no different with DFINITY. Collaboration is also required. And it's required to get consensus on the state of its virtual machine after the execution of code or storage of data. And so as you may know that executing code and storing data inside any virtual machine is going to utilize resources of the host machine. And so that's true for any host machine that participates in the DFINITY protocol. And actually, it's true not even just for DFINITY. I mean, with other virtualization or even containerized platform or containerized environments as well. There's usually some level of resource sharing between the guest and the host. And so the idea here is that with that resource sharing is that we need to provide the operator of the host machine with an incentive to offer up these resources to be utilized by the network. And so there is a unit of computation defined there. It's kind of like a this notion that of a token that does provide an incentive for people who are participating in the protocol to continue to do exactly that. And then actually, I kind of maybe briefly about just one side note about collaboration and what you're kind of seeing in this picture here. So DFINITY, the protocol itself is a committee-based protocol, which means that this is different nodes will collaborate at sort of at discrete points in order to, like I said, figure out what is that next, how do we define the next state of this virtual machine. And so with DFINITY sort of at the lowest level of this collaboration, we actually have these nodes in a network. Actually, each one of these dots just represents a node in a network. And these committees, they get together actually to produce a sequence of random numbers. So every single time you see these green dots shift, this actually is some subset of the nodes getting together to actually produce a random number. And this is actually DFINITY at the absolute lowest level of the protocol. Is we kind of just like to think about it as what's called threshold relay, but it's a sequence of random numbers that's generated. And when that group collaborates to actually generate that random number, what they use is they can use that random number to sort of select amongst themselves someone to propose what the future state of that virtual machine should be. And that once that person selects it and puts out that information across the network, the same group that actually selected that person in the first place notarizes what the state of its virtual machine is. And this process continues over and over again. An important aspect here of DFINITY is that or important characterization is that of DFINITY as a computing resource is that computation and storage is actually proportional to the number of participants in the number of host machines that are actually participating in the protocol. And as more host machines come in to participate, that means that we can do things like install more software on this computer, run more computation, and store more data. Okay, so what will what will run on the internet computer, as we've defined it here now. So as previously stated, we want to be able to run software in the widest variety of application domains. And to run general purpose software on a general purpose computing resource, you need an assembly language that is the build target of general purpose programming languages. I think most would agree with that. And we have a really nice solution here, and it's not specific to us, but some of you may have heard of it. But how many people, just by show of hands, have heard of WebAssembly? Okay, well, that's much less than I thought. So if you haven't heard about it, I would encourage you to go up and do some background reading. It's a new standard that's come to the web now, and in fact, it's an assembly language that's supported inside every major web browser, I think, as of October of last year. So the idea, yeah, Chrome, Firefox, Safari, yeah, and so, okay, so the idea is like if we're doing kind of computing on the web, how many of you are familiar with JavaScript at least? So, okay, a lot more of you, great. So this is some baseline here. So you may find that you want to be able to execute some code in the browser that is not actually written in JavaScript, and now you can do this, right? WebAssembly is a target assembly language of many different compilers. In fact, basically anything that has an LLVM backend can now generate WebAssembly, which is really cool. So it means that if you want to actually run some computation in the browser, you can actually write code in C and C++ now, and you can compile it down to WebAssembly, and then you can execute that WebAssembly inside your browser. And I guess the point here is that all major web browsers, they now understand how to execute this code, whereas, yeah, it's getting everyone on the internet to agree about a new web standard is a really difficult thing to do. So the fact that we have WebAssembly now is actually a huge, huge accomplishment. But it is also then it is also actually the assembly language that we use to run computations on DFINITY. And it has a lot of other nice, important properties that I mentioned. Like I said, you can compile from many programming languages down to WebAssembly, also including anything with an LLVM backend. But just think about this. If you can compile C and C++ down to WebAssembly, what if your compiler is written in C and C++? Well, now I can compile my compiler down to WebAssembly. Okay. Now I can compile my compiler down to WebAssembly. And I know that I can execute WebAssembly inside my browser, so I can now have my compiler actually run my compiler in my browser, which means that I can literally write C and C++ code in my browser, compile it to WebAssembly in my browser, and WebAssembly is the assembly language that's understood by DFINITY and its internet computer. Which means that you could basically, once you generate that code inside your browser, you can actually sign it the same way you sign transactions on Bitcoin or Ethereum, for example, and then deploy that code on the DFINITY network. And actually, you could actually take this even further. It's one of the things that I'm pretty excited about. Also, so when that's deployed on DFINITY, so all this is to say that all transactions on the DFINITY network are really just WebAssembly binaries. And more importantly, you can actually load WebAssembly binaries from the DFINITY network itself. So which means that I can write C and C++ code in my browser, compile it down to WebAssembly in my browser, deploy that code on DFINITY from my browser. And moreover, I can take WebAssembly modules from the DFINITY network, load them into my browser, and be able to compile and link against them to keep with the development cycle. So the idea is to just try to create this environment in which there's zero friction whatsoever for developers. And maybe something actually even cooler here. So if I can compile my compiler and get it running inside my browser, but that's just my browser's just executing WebAssembly, but I also know that DFINITY executes WebAssembly, I could deploy the compiler itself on DFINITY. And so what does that mean? What does that mean? That means that I could now actually, these WebAssembly binaries that I've created, I can send it to that DFINITY's actor model, if you guys are familiar with that. But I can send that WebAssembly binary then onto the chain. And now what that means is the compiler can run that build process on chain, and now I have secure reproducible builds. Yeah, so that's, I mean, I think it's pretty incredible. I don't know. Yeah, so I mean, like, as opposed to a conventional way, maybe you're a company and you've got a build server or something, or Jenkins or BuildBot, or whatever your favorite build system is. I mean, they're pretty good points if you're trying to hack someone's system. Targeting a build server is a pretty cool thing to do, right? Because if you can get yourself inserted in the build server, then you can inject all kinds of backdoors and vulnerabilities into code that gets generated and distributed on the internet. So yeah, the fact that we have this on a blockchain, which is this entirely secure and tamper-proof environment that's doing this, is I think is fantastic. So okay. Some other interesting notes about WebAssembly more generally is that has a very close mapping to like x86, 64, and some other assembly languages. So it's really fast, like blazingly fast, because a lot of low-level optimizations that you can take advantage of there. Okay, let's go to. So where did DFINITY come from? Okay, so as I kind of already alluded to, it's pretty deeply rooted in blockchain. Although I don't like to think of DFINITY as a blockchain project, but you do have all the properties of a blockchain. And sort of doing this kind of decentralized computing isn't new, and did to a certain extent grow out of Bitcoin. So let me just kind of explain that. That's because there is this notion or this idea that you can do these kinds of computations on Bitcoin, right? It's this, we know it as like this value transfer network, but we can kind of think of this value transfer network as really doing some very primitive types of computations. If I want to send one of you guys a Bitcoin, I sign this little Bitcoin transaction with my private key. I broadcast that signed transaction to this network. This network reaches a consensus on that transaction. Transaction gets included in a block, and the block gets appended to the chain. And now the state of the system is that you have one more Bitcoin than you did before, and I have one less. But we can think about this as a very primitive type of computation, right? It's this addition and this subtraction together with this conservation property that the same amount of Bitcoins went into the transaction came out. And Vitalik kind of grew on this idea, and he said, well, why are we signing like these very primitive addition and subtraction type scripts? Like, can't we do something more general, right? And he said, okay, well, what if instead of we were signing these Bitcoin scripts, what if we actually just, what if we're just signing bytecode? So I sign this, in the case of Ethereum's EVM bytecode, I sign this EVM bytecode, I broadcast this bytecode to this network, and now the network reaches consensus on the execution of the bytecode. So it actually was pretty significant, and it was a huge development at the time, and I think a lot of people were fascinated by it. They were then, and many people still are today. But obviously, very quickly, I think that we ran into a lot of limitations with Ethereum, and kind of stumbled on all these scalability challenges that I think we all hear so frequently about, and why there's such a strong motivation to sort of really take blockchain technology to that next level. And so, of course, on DFINITY is something new, in which we really try to tackle a lot of those limitations with performance, a lot of the limitations that we have in terms of storage, and to make it less expensive to store things on chain. Which, if you guys have used Ethereum firsthand, then you know exactly the problems that I'm talking about. Let's see if I. Okay, and so what are some of those huge performance boosts that you get with DFINITY now, in sort of like when you look at third generation blockchains? I suppose what DFINITY is probably most well known for is bringing down transaction finality by an order of magnitude. So where transaction finality is defined as how long does it take in order to say with overwhelming probability that a transaction can no longer be reversed, right? So if I sign that Bitcoin script and I send it off to the network, I know that maybe some of you have heard, you need 6 confirmations in order to get to finality, right? So 6 confirmations, 10-minute block time. So an expectation, it can take 1 hour for that transaction to get finalized. Ethereum is a much faster block time, but the number of confirmations that you need is much higher, 37, and I think it works out to be 10 or 15 minutes, somewhere around that. Whereas on DFINITY, it's a few seconds, less than 5 seconds right now, which is pretty amazing. And I guess one of the things that excites me really about bringing transaction finality down by an order of magnitude in particular is that we've seen this sort of win across the board in science and technology, is that whenever we are able to make these leaps on an order of magnitude, that a lot of new discoveries were made. And like, for example, I in another lifetime, it seems like, I worked at the SLAC National Accelerator Laboratory, which is a nuclear and particle physics lab operated by Stanford University for the Department of Energy. And the lab, when I was working there, the lab went under a major transformation, and we converted this big particle accelerator into this laser. And this laser is so, well, I guess I won't get into the technical details, but basically it was able to sort of emit light on the order of femtoseconds, like 1 × 10⁻15. And this was a huge leap in terms of orders of magnitude that no one had ever been able to do before. And lots of new discoveries were made. And I guess you see this, not whether it's particle physics or blockchain, or I feel like you see this around the world with different advancements in science and technology, is that when you do make these leaps, that new things become possible. And I think for DFINITY, I think that will be largely manifested with new types of applications that are that are particularly latency sensitive, that may not have made sense on Ethereum, but may make a lot of sense to do on DFINITY. So that's something that excites me a lot. And yeah, let's just go through a couple of. I won't go through all of these in detail, but private software systems, decentralized business infrastructure, decentralized internet services, decentralized finance, and then obviously really technical things like on-chain build systems and things like that maybe I'm more excited about. Yeah, again, I won't go into all of this, and these are just a couple of different areas that I think will definitely see some big changes once we move to these move into a system in which we have a blockchain with these types of properties. I guess for us right now, invoice financing and supply chain is the largest in terms of people interested in building on DFINITY. It also supports things like ICOs, although that's not really the purpose of DFINITY, but it does support that kind of thing. So I briefly mentioned actually earlier that DFINITY uses this underlying randomness to actually do this protocol. And so one of the things that's really cool is that you have access to randomness. So that could be things like decentralized gambling or casinos. So there's a lot of people who happen to have interest in that too. But also different kinds of social media type things. Like one of my colleagues created something called Chirp, which is like a fake Twitter. So it's just we're just kind of we're at a state right now. We're just kind of experimenting and seeing actually like what's really possible. But it's a general purpose computing platform, so lots of things are possible. So we're looking at everything, and I'm very excited. Yeah, with just a couple of other features, I kind of touched on some of these. We do have a layer for privacy protection. Of course, the kind of things that you already know about: hack-proof, actor model, just autonomous software. This is just once these programs are deployed on the chain, I mean they can run indefinitely, and yeah, get some really cool. You can do really cool things with that too. Also, I think one of the things that's maybe not discussed enough is actually lowering cost of R&D. I mean, there's a lot of for a lot of infrastructure. I mean, we spend a lot in terms of people's salaries to paying people to actually maintain systems, and sort of with the idea of this internet computer and having the computer that can sort of run this software much more autonomously. There's arguably a lot of cost savings there. Which is Oh, okay. So yeah, moving on. So okay, so how is something like this going to be controlled? So sounds like a really cool, interesting, really next generation project. Certainly, something a project like that is there's going to be a lot of people with a lot of different ideas about how do you how do you decide what features should be integrated and which ones shouldn't. And so there is this notion of a governance mechanism for DFINITY. We call it algorithmic governance, and so there is a way of that's entirely decentralized of people who are participating in the protocol to actually decide how we want to kind of move forward, and not really allow that control to be passed on to any one specific person or people. Oh yeah, okay, so just some other notes here, just briefly on the team. I have to say, it's a little biased because I'm working on the team, but I have the utmost respect for my colleagues who are working on this with me. We involve a lot of people who have kind of come from the blockchain space and some people who have come from WebAssembly and some other parts. It's a really complex project. This piece of software in particular, I mean, it literally touches on every single aspect of computer science, from cryptography to distributed systems to networking to virtualization to storage. I mean, it touches a lot of things. So we have a pretty awesome technical staff who is here helping each other out, and just in particular, a couple names. Andreas Rosberg, who I think he's either from Munich or maybe he's from Berlin. He's from Munich. Okay, great. Yeah, wonderful. Yeah, so he's actually the co-inventor of WebAssembly, which he worked on when he was at Google working on V8. We have Ben Lin, who actually has developed the underlying cryptography when he was a PhD student at Stanford, and one of my colleagues, Paul, who wrote the Haskell compiler at Intel, and yeah, there's many other names there. Timo Hanke, Mahanush, Martin Bexey, who came from the Ethereum Foundation, and then of course Dominic, who should have actually been the one to give the talk, who created Threshold Relay in the first place. So without him, none of this would have been possible. And so yeah, so I think we've built a really awesome team. I think and I think we're really excited for where this project is going. Just some other notes about DFINITY. We do have an ecosystem fund out now, partnership with Polychain Capital in San Francisco and Wangsheng in Shanghai, who have I think I don't know what the amount is. I think Polychain is 40-something million, and Wangsheng is somewhere on that order of magnitude. So these are funds that are created to actually develop new types of products and services on top of this this computing resource that we're building. And so if any of you guys are interested, there definitely is opportunity to connect there. And then just more about our team. We're pretty geographically distributed here, but most of us are in headquarters in Palo Alto, which is in Silicon Valley. And let's see what else. Okay. Yeah, I think that's it. I think we're gonna jump into Q&A, but it's just some contact information for you guys to stay up to speed with the project. Our website is just DFINITY.org, and either Dominic's Twitter or I think it's just at DFINITY also. So awesome. All right, thank you guys.
I have some questions prepared just to get started, and I will continue with the questions from the audience afterwards. So, yeah, Enzo has really dived into the implementation side of things, which is great because we can ask him detailed questions about how DFINITY works on that hood, which is really interesting. So, maybe we could just briefly touch on randomness again, just because it's a so important property. So, and so, why is it such an valuable thing to have in a decentralized setting, this strong randomness?
Oh yeah, I mean, there's a lot of reasons there. I mean, I suppose that the app kind of maybe taking that, looking at on a high level, within the context of developing some software. I mean, sometimes you're writing some computer program and you want access to randomness. If I'm doing a Monte Carlo simulation or something, I need a random seed. Right now on Ethereum, I don't really have the ability to get that, or not in a way that where I can be totally convinced that the randomness itself has not been biased in some capacity. So having unbiased randomness on the application layer, especially when you're doing things like cryptography or running a casino type application, in which the randomness not only is the randomness that is there, but is totally and completely unpredictable. So that's on an application level. On a lower level, on sort of at a more foundational protocol level, I would say that having access to randomness has helped really solve a lot of problem. It just, I guess it turns out on the implementation side that sometimes having access to randomness, you can solve things a lot more elegantly. And I give you guys a great example of this is how we deal with Sybil attacks in DFINITY. So if you guys don't know, imagine that there are computers that are participating in this protocol, right? So what happens if you just allow anyone to come in and participate in the protocol? You may imagine that an attacker who has a lot of resources can just spin up, some big, server farm and get him and his servers injected into different parts of the network. And then when that attacker decides that the time is right, he flips a switch, and then all of those computers that were participating in the protocol, they start dropping packets, sending junk data, and really just hurting the throughput of the network. And even if the nodes themselves have pretty good DOS protection there, and they're able to recognize when someone is misbehaving, there's nothing that prevents that same attacker from going out to some other data center and firing up some new instances and relaunching the same attack. So he just launches the attack over and over and over again, to the point that the network just becomes unusable. And so how do we it's a hard challenge that a lot of these projects have to deal with. And so in DFINITY, we have a very elegant solution for this, in which we have a way of making those identities, the identity that is required to join the network in the first place, to make it expensive. It's a proof of stake protocol. And then actually by not just making it expensive, but making it marginally expensive. And by that I mean that if you want to get one node in the network or a second node in the network, if you have two nodes in the network, it should be twice as expensive as for me to get one node, and 3 times as expensive if I want a third one, right? And so on and so forth, sort of with that linear scale. And so in order, it turns out that the only way that you can really effectively implement this is by constraining the routing. And to have constrained routing in a way that's secure requires access to shared randomness. And so it just turns out on DFINITY that we have access to the shared randomness, and so we have a solution to this problem with how do you address Sybil attacks in a proof of stake network, for example. But that's one example. There are many other places where randomness can also be useful, but I'll leave it there.
Yeah, that's cool. I've looked at it, and randomness is important in so many places in this protocol. It's really amazing. So, for example, if you think about who can propose the next block, if it's known to the network who will be the next one who is able to produce a block, this person or node can be targeted and attacked, But if it's completely random who is the next block producer, it's essentially impossible to know who is going to be next. So this guy is also not being targeted, because there's no way of knowing ahead of time that he will be the next one. So it's pretty cool. One thing that interests me a lot is the peer-to-peer layer. So it's not often talked about, but so what is it, maybe for people who are not familiar with it? So essentially how nodes communicate, they communicate in a peer-to-peer fashion. So there's no central hub or anything that controls the flow of information. It's all peer-to-peer. And each node should be equally privileged, I think, in this kind of protocol, we don't want any kind of second-class citizens. But like what we have seen in historically and in reality is that exactly this is happening. So for example, in Bitcoin, we have this Bitcoin relay network is essentially like a private side network which connects all the big Bitcoin miners, and they use it to exchange information about new blocks quickly. But it's essentially a closed circle. You know, there are some guys in a chat room who are deciding who is able to join this protocol and who's not. So that's really bad, and we don't want that. So my question would be, what problems do you see with existing peer-to-peer solutions, and how does DFINITY work in that regard?
Yeah, and I'd say it's actually not really that much different with Ethereum either. I mean, everyone just kind of connects up to the foundation supernodes, and it's the same deal. Yeah, I mean, so it like as I kind of alluded to previously, we do constrain the routing, so you can't really decide who it is that you talk to. The randomness actually decides that for you, and it's everything is entirely symmetric on the P2P level. So you don't have like more outbound connections than inbound. It's everyone is just kind of evenly paired, and yeah, we've thought really hard about how someone might be able to sort of game the system, and yeah, if there was a known problem with it, we'd have found a solution for it. But I think I'm pretty happy with what we have in terms of constrained routing, and yeah, there isn't. You look around and what's out there, and I don't think that there's anything that kind of even close to that.
That's good to hear. So my last question would be about storage. So storage is another core component of any blockchain. So you need storage, and storing data on Ethereum, for example, is very expensive. I actually looked it up. For 1 megabyte of data, you have to pay $2,000, so $2,000 US. Of course, you shouldn't do that, but you know, just to get a sense of how expensive it is to store data on a blockchain. So, how can a separate like storage layer help in that regard, and what's your approach to that?
So it's actually, I mean, mostly sharding is the solution there, right? And of course, you have this idea in DFINITY in which the amount of computation and storage is proportional to the number of nodes that are actually participating in the protocol. Each shard, they do their own. Each shard does either each network that's around a shard does its own in order to get sort of a common state root, and then there is a higher level protocol that exists on top of that in order to unify these shards, which is also based on threshold relay. Yeah, so I don't know. So, okay.
You want to start? You had a question.
Yeah. So just maybe to get a better understanding, you mentioned that the more nodes enter the network, the more storage it has and more computation. Could you elaborate a little bit on the scalability of the network and how this compares maybe to Ethereum's problems?
Yeah, so unfortunately there's like 3 things I can't talk about. I can't talk about privacy, I can't talk about sharding, and I can't talk about who our customers are. So I would say that few people have really made any meaningful progress toward scalability challenges, and I'm really confident in the solution that DFINITY has going for it. And right now we're in sort of a unique set of circumstances in that, like I said, we want all the code to be out there and in the public domain, but we also have a lot of competing projects. And so for us, we'd really like to sort of see the bad design choices in the other projects solidify before we rush to put our solutions out there. So that's the state there. But okay, next question I can. Okay, yeah.
What are your biggest competitors in this?
Oh, I mean, obviously there are a few third-generation blockchain projects that are not looking at WebAssembly in some capacity. Obviously, EOS would be one of them, and Polkadot. Just anyone who's big and raised a sufficient amount of capital and is looking into WebAssembly, kind of see as a competitor. But for the same token too, I also don't really see them as a competition because I'm a little biased and think that what we have is much better. But I mean, sometimes you don't know what you don't know. For some of these projects, I mean, they also have things close. Some of these other projects definitely we know have some things going closed source. So don't know what you don't know, but I feel pretty confident where we are right now and getting something out pretty quickly. Thanks. Next question, yeah.
Follow up on that. Can you give us some input on when the testnet will be available?
That's the question my boss asked me like 10 times per day. Yeah, I think I would characterize it as such. I think that we are very close right now in that for us, I don't believe that there are that many unknowns going around. I think for the most part, we're at a state right now where we are really just focused more on code quality. We're focused more on testing for vulnerabilities and things like that. We really are in kind of much more the final stages, and I'm hoping that we'll have something out by the end of Q3, but I think it's quoted as Q4 as in case things run behind schedule as they often do. But yeah, so in short, I think it's probably just a couple of months away. I mean, obviously we've had a very stable testnet running internally for I guess since October or November of last year. So yeah, I think things have been pretty stable, and yeah, getting WebAssembly baked into DFINITY was a huge challenge. Dealing with dynamic member strip for the proof of stake protocol was a challenge. But they're all it's all just there's just tricky things in the implementation details to work out. But yeah, I think we're not in a state like where we're trying to solve some unsolved problem in cryptography, and there are some projects out there that are have raised a bunch of money and claim that they have a solution to something that they really don't. And I think that they raise the money and they think that maybe, oh, if we have this, then we'll figure out a solution, which they may or may not. So yeah. Next, yeah.
You can have one of those.
Oh, okay.
In between. So, one question from Anonymous. Is network bandwidth a limiting factor of the internet computer, and will its capability scale with faster connections?
Yeah, I mean, I think, well, we have a specification coming out on how much bandwidth that you need to run a node, which I think is 750 megabits a second. But yeah, well, how do I say it? If you would need to be, like I said, because of the constrained routing, you do need a lot of access to bandwidth for DFINITY. That's just something that you can't really do without. You need the resources to participate in the protocol, and there's no real faking it. If you don't have the right resources, then you won't be able to calculate the state root. And if you can't calculate the state root, which this is a state root is what defines what the state of the virtual machine, and if you can't calculate that, then you can't your resources will not be able to progress. So if someone else has more resources than you, then you ultimately, yeah, you'll fall behind if you don't meet the minimum threshold.
Cool. Does it need a lot of resources, likely energy, to set up such a blockchain?
No. I mean, well, yes and no. I mean, relative to the amount of energy that's used to consume Bitcoin, definitely not. I mean, with Bitcoin, I mean, you have most of the energy waste in hashing, whereas DFINITY is a proof of stake protocol. I mean, there is computation that's required to do the base level consensus, which is pretty minimal. It's 200 BLS, 200 validations on BLS signature shares, and then beyond that, I think most of the crypto though can get done. Well, on the testnet that we have, I think we do all the crypto we need to get consensus going in like less than a second, so that we can spend the next couple of seconds actually executing computation. So beyond that, no, it's not the same kind of. It would be comparable to the amount of energy that you would spend on running a data center, but it's not like you're wasting your electricity.
Yes, I just read that Bitcoin is consuming as much energy as 2 Denmarks. It's 2 Denmarks. It was one just a couple of months ago, yes. So 2 Denmarks now. So another question is, how do you think your technology will change the digital marketing industry? Thanks.
I don't know that I'm close enough. I don't know that I'm close enough to digital marketing to be able to say anything with any certainty. That's not my area of expertise. Sorry.
So whoever asked this question can look at like Brave or the basic attention token. Enzo mentioned that you can put a price tag on your data. No, you said that. So that's Brave is trying to put a price tag on your attention, so that your attention, which is actually worth something, can be formed, like morphed into capital if you consume ads. So that's pretty cool.
Just one more question. Right now, a lot of corporates are also trying to figure out what they can do with blockchain, and they always have this requirement of keeping information private, like legal requirements here. How could corporates make use of DFINITY, or is that the wrong space for them?
So I mean, we do have the ability to keep data private on DFINITY, and so that gets to the second of the 3 things that I can't talk about. No, I think that we have a really innovative privacy layer, and there isn't anything I've seen that is even remotely comparable. But yeah, I mean, the idea is that you can have keep the data encrypted actually as it's stored on chain, as is viewable to others, and then having the ability to perform computation on that data in an unencrypted form. That is possible. And so from that perspective, there's a lot of things like that you could do, and to also make sure that when you actually are performing computation on that encrypted data, that even that when it's unencrypted, that even the operator of the host machine has no ability to actually see the contents of the data. So there's a way to do that. Yeah. And okay, I just gotta leave it at that.
Any more questions?
Just briefly, you mentioned a lot of risks with proof of stake. Could you maybe go a bit more into detail what those risks are, and how you're kind of, I know you can't talk about it in detail, but just how you trying to avoid those risks?
Oh no, I can't talk about that. In fact, we're gonna have a paper coming out on that pretty soon. So we have, I think, one paper that maybe a lot of you have read, which is on the DFINITY's consensus mechanism. We have 8 papers in the works. The second paper is actually on the constrained routing and how we deal with Sybil attacks in DFINITY. So the challenge in any proof of stake network is, as I was kind of trying to articulate before, is how do we make it so that an identity on the network is expensive, right? Because even if an identity cost, even if there's a cost associated with some identity, right? I've made my stake deposit, if you will. So I've deposited some stake and I have an identity. The question is with that identity, how can I get myself connected into this network, right? And then, so even with some proof of stake protocols that I've seen, they do have the ability to make these identities expensive, which is great, but they're not marginally, there's no marginal cost associated with that. And that I buy this one identity, and with that one identity, I connect to many different people inside that network. So even if, even like I said, even if when I launch my attack with this single identity that is inserted in many different places. I mean, we don't know the whole system, right? Like, how do I say this? If you and I have no direct link between one another, right? But Wolfgang has purchased this identity which he wants to use to attack the system, and he connects to me, and he also connects to you, but we don't know that we're both connected to him. Then it's still, you still have a situation in which Wolfgang can launch this attack now, right? He can pay for this one identity, and he can DOS you and DOS me at the same time. And even if you and I have good DOS protection, and we see that Wolfgang is doing things he's not supposed to do, remember, Wolfgang only paid for one identity, but got himself positioned thousands of times inside this network. He's still able to, even at a very low cost, depending on what the cost of this identity is, do significant damage. And then the question is well, like, what does one identity cost? Does one identity cost, you know, $200? Well, you know, if I'm EOS and I've got $4 billion on my balance sheet, well, that doesn't really seem like a lot of money, and I could probably just do that attack over and over again, even if it doesn't cost me that much money. You know, if this is my competitor and I want to you know, make this network unusable, then I can do that, and there's nothing preventing anyone from doing that. So like I said, there has to be this marginal cost, and I think it's a big thing that a lot of people who are doing proof of stake, it's a big thing I think that they're missing, is how do you make it so that how do you make it so that you can only get connected into the network as much as you paid to be connected.
Cool. So another question is, are there any limitations on what computations can run on DFINITY? Anything that would not work in such a kind of system?
So that, I mean, the question would be more generally, what are the limitations on WebAssembly? I would just refer you to the WebAssembly specification for that. I mean, WebAssembly is trying to be general purpose for the web, so it was designed in such a way that we could be as flexible as possible, but some things are not. And actually, I would say there is some constraints that we have on top of WebAssembly that WebAssembly does not. We also require deterministic computation because other people on the network have to be able to calculate the same state root, so the computations themselves have to be deterministic. So like comparison of NANs, for example, is like that's not that the sign of the NAND value is CPU specific, so that, for example, is one thing that like that's a piece of non-determinism. And so actually when a WebAssembly binary is actually sent to DFINITY or to a DFINITY node, that node actually has to parse that binary and do some validation to detect whether or not there is any amount of non-determinism. So that's a limitation.
There's this notion of gas still, right? So
but there's still a notion of gas. If you characterize that as, I guess that's the obvious.
I'm just thinking about it because I saw that Dominic showed it in a video that it's possible to run applications over the time span of multiple blocks. So recurring task. That's not a limitation. That's an advantage. I don't know. There's any. I don't know that there's any other anything else out there that can do that. Yeah, but we do have the ability to run daemon, like what would be kind of like we call daemon process, but yeah. So I have one last question. What barriers to businesses implementation might your technology have? You can try.
Yeah.
Sure if I understand.
I mean, it's like I said, we really tried to create the simplest programming model possible. I think one of the problems right now for other businesses that are looking at different chains is they can be very hard to use, and sometimes the tool chains that exist around them can be many of them they're developing, or they're just really not that good, and it can be hard for sort of average developers to try to move past some of the hurdles there. And like I said, I mean, we tried to create an environment in which we have the simplest possible programming model, in which you're literally just writing code in your browser, signing it, deploying it on chain, being able to load code from the network and be able to compile and link against that, and then just kind of keep with a cycle, and then also be able to deploy kind of whole classes of applications onto the network, in which you kind of have packaged up multiple WebAssembly binaries. So we have this notion actually of a web canister. We don't have a slide on it, but I mean, a lot of people right now who are building systems, right? Like, okay, here's my Docker container, and I put it on, the EC2 container, serve it, running it on EC2S, or yeah, I forgot the acronym now. Amazon has so many services. No, EC2 is just virtualizations. It's the containerized one. But yeah, so the same kind of concept is that in my web browser, I can create a web canister, and I can deploy this web canister on this internet computer and interface it with it in many of the same ways that I would interface with a web server, for example, except that I get some really nice, cool, and unique properties by doing it on DFINITY.
Thanks. One more.
In the future, have you already given thought about how you will make profit from it if the internet computer is finished, is ready to be used for companies or for private persons?
Yeah, I mean, so the point of the foundation has a mandate really to just incubate the network, and to try to put the network in a state that really that anyone can do anything that they want on top of it. Is not just to say that the foundation is selling per se to corporations, although many corporations have approached the foundation directly for assistance. But most of the corporate outreach for DFINITY is done through a variety of partners, and I think the one of them that's publicly disclosed is BCG Digital Ventures, and through them we work with several different Fortune 500 companies who are interested in building mostly new products and services on top of this network.
Yep. That's a question on Slido about the token, and also would be interested in how to purchase a token.
Yeah, I don't know. It's really tricky thing in the United States is like whether or not something constitutes a securities offering or something. I don't know enough about that, but there is a token, because there does have to be an incentive for someone who's operating a machine that's participating in the protocol to perform certain computations, and there is a token which is a unit of computation. But how do you buy them? I don't know, because I just focus on the engineering aspect, and even then it's pretty mostly involved on the implementation side. But yeah, I think that there was originally there was an ICO. There was a scheduled 2-phase ICO, but then that got canceled because of regulatory issues within the United States. The project is based in the board of the foundation is based in Switzerland, in Zug, and it was structured by the same people who set up the Ethereum Foundation and many others. Pretty good law firm there. But that said, but a significant portion of the technical staff actually resides in Silicon Valley, and so I think we don't, you know, a lot of time and effort has gone into this project, and we're not going to see, we're not going to allow ourselves to get into trouble with a regulator because of some, you know, new laws that are unfolding.
Any more questions? Otherwise, I think we're done. Yeah. So thanks a lot, guys.
Okay.